Yeah, welcome to the YouTube application of Coulomb's law. That's what we are doing. And what I have for you today is the question that says a particle of charge Q1 equals to plus 6.0 microcoulomb is located on the x-axis at coordinates x1 equals to 5.1 cm. A second particle of charge Q2 minus 50 microcoulomb is placed on the same x-axis at x2 equals to minus 3.4 cm. Then I said, what is the magnitude and the direction of the total electrostatic force acting on a third particle of charge Q3 equals to plus 2.0 microcoulomb placed at the origin? Where is it placed? At origin, which is x equals to 0. I'm repeating. A particle of charge Q1 plus 6.0 microcoulomb is located on the x-axis at the coordinate x1 equals to 50.1 cm. The second one, a second particle of charge Q2 minus 50 microcoulomb is placed on the same x-axis at x equals to minus 3.4 cm. What is the magnitude and direction of the total electrostatic force acting on the third particle, charge Q3, which is 2.0 microcoulomb, placed at origin? Look at it. Look at it. We have coordinates. You remember our coordinates? Look at our coordinates. This is what x-axis. This is what the same x-axis. This is y-axis, and this is the same y-axis. Look. This point is what we call origin. Then, this side is a positive side of x. This side is a positive side of x. This side is a negative side of x. While this side is a positive side of y. And this side is a negative side of y. I'm repeating again. I said this side is a positive side of y. And this from this origin down here is a negative side of what? Y. From this origin, like this, is what? Positive sign of x, and from this origin, like this, is a negative sign of what? X. Then you remember, Q3 is placed at origin, meaning this point. We'll have Q3, which they said is what? Plus 2.0 microcoulomb. And which means 2 times 10 raised to power minus 6 coulomb. You remember? Micro. This micro stands for what? 10 raised to power minus 6. You remember that? Then the second charge, which is what? Q6.0, is located on the same x-axis at what? 5.1 cm. Means that is a positive. Look at the 5.1 cm positive side of x. That means at positive side of x, I will call it what? Q1. That's Q1. And what's the value? It said is what? 6.0 microcoulomb, and which stands for 6 times 10 raised to power minus 6 coulomb. Then the third one, which is x2, is located at what? Negative, which is minus 3.4 cm, meaning at the negative side of x, which I'm taking it to be at this point, which is what? Q2. And the value is minus 50 microcoulomb, which stands for what? Minus 50 times 10 raised to power minus 6 coulomb. Then, they told me that from here to here is 5.1 cm, which is distance of separation of this man to this man. Then here, they told me that is what? Minus, which is from here, which is minus what? 3.4 towards this. That's the distance between this. Then now, let us go to this to clear ourselves. Then this man, which is minus 50 microcoulomb, is indication, this minus is indication that this charge is a negative charge. You remember that charge is a vector quantity. Charge is a what? Vector quantity, which has the magnitude and direction. The negative here is just telling me the direction. Y50 is the magnitude. So what this thing is telling me that this charge here is a negative charge. Then this plus here is telling me that this charge is a positive charge. Look at it. I want to know the force that is acting on them. Then this man is also positive, telling me that is what that charge is a what? Positive charge. Then now, what they ask me, what will be the force? This is Q3. This is what? Q1. And this is what? Q1. This is Q1. This is Q2 in the diagram, in our diagram over there. They told me, what they asked me is the magnitude of force, which is what? Electrostatic force acting on 3, Q3. The force that will act on Q3, which will be as a result of what? Force from Q1 on 3 and force from Q2 on 3. Force from Q1 on 3 and the what? Force on Q2 on 3. That's what they're asking me. The magnitude of force of Q1 on 3 and what? Q2 on what? 3, which is total force. Means that this Q3 is what I'm looking for. For example, I said, for example, if you have a coin and you are playing on the sandy sand and that coin lost on that sandy sand, you couldn't be able to see the coin again. Normally, you can go and get magnetor. That magnetor acts as a vortex charge. While the coin on the sandy soil become an isolated charge. So you will now get your text charge to use it to what? Look for that what? Coin. Then when you are holding the magnetor and come closer to that what? Coin, if the magnetor you are holding is a positive charge and that coin that is in the what? Ground in the sandy side is a what? Negative what? Charge, and the one you are holding is positive charge, what will happen? It will lift itself from that soil. Immediately you come closer to the field, it will lift itself and magnet to the one you are holding. Are you getting what I'm saying now? Then if they are the same charge, maybe the one I'm holding is positive and the coin I'm looking for is positive, what will happen? It will lift itself from that what? Sand and move away. It will run away from there. I'll be able to see it and go and pick it. So then now let us look at it here. This one is the charge I'm holding in my hand, which is called vortex charge. This one now is what I'm holding in hand again, text charge. Why this one is called isolated charge, which I'm looking for. I'm searching for it. Then this man will hammer on this. This man will hammer on this. That's what they asked me. The force of this man on the isolated charge and the force of this man on the isolated charge. Let us look at the force. Then I'm holding this charge coming to this man. What will happen? Look at him in the sand. He's in the sand now. I'm holding this charge coming to him. What will happen? This direction. You know they are on x-axis. Look at it on the x-axis. This man coming in this way, coming closer to this man. What will happen? It will move this way. Is it not? According to my explanation, it will move this way. It will run away because they are of the same charge. They are of the same charge. It will move this way. What happens? I'm coming this man close to, taking this man, the one I'm holding in my hand, coming closer to the one I'm looking for. What happens? It will run away. It will just move. As move, it becomes force of what? 1 on what? 3. This becomes force of this one on what? 3. That's why I first write 1. Force of 1 on what? 3. Then again, this man is a what? Is a negative charge, which I'm holding in my hand. Look at this negative charge, which I'm holding in my hand. Coming closer to this man, what will happen? Can somebody tell me? According to my explanation. This is positive charge, this is negative charge. What will happen? This man will lift himself from the ground and follow me. It will follow me. Not me that will follow him, because I'm holding this one in my hand. This one is movable. It will just move and come closer to it and what? Magnet to it. On what direction? The same this direction. It will move this way. That shows me that the force of Q2 on what? 3 is the same direction with this man. So the force acting on this man, Q1 is this what? This, and as well this one, this way. I can write it this way. Do you understand? So since the force is moving in the same direction, the resultant force, Fr, which I call resultant force, and is what? A force on what? Q3, which is equal to the summation of the whole force, which is called Fi. and it become the force of this man, which is acting in this man on the Q3, plus the force of this man, which is acting in the same direction of this, become this 2Q3. Understood? You see, the two forces are acting in the same direction. This will attract to this way. This one will push this way. I get what I'm saying? They are going the same way. So I sum it, add it together. Then since I have done that, I have begin to look for the force. How do we look for the force? And I said, coming over here, I said F1 on 3 is equals to K Q1 and what? Q3 all over R squared. That's distance of separation. Remember, I'm now applying the word Coulomb's law. What I'm applying now is the word Coulomb's law. That's what I say, application of Coulomb's law on the question. Then now, where R is giving to me the distance between what? Q1 and Q3. Look at Q1, look at Q3. What's the distance? 5.1 cm. That's 5.1 cm. I have to convert it to meter. You know the reason? The value of K is given at the value of K, which you say K is equals to 1 over 4 pi epsilon O, which is equals to 9 times 10 raised to the power 9, and the meter per watt force meter. I have to change this to meter. That means what? 5.1 divided by 100 when we want to change to meter. And that implies that R is equals to 0.051 meter. You're following me? Then now I can now say that F what? 1 on 3, charge 1 on 3 equals to, substituting the value I have 9 times 10 raised to power 9 times what? Q1. What's my Q1? Is 6 times 10 raised to power minus what? 6. Look at Q1 here. Look at Q1 here. Look at it. Q2 is 2 times 10 raised to power minus 6. Then Q3, I mean to say, Q3 is 2 times 10 raised to power minus 6. And I said 2 times 10 raised to power minus 6 all over the distance of separation, which is what? 0.05 all what? Squared. Remember, according to our formula, this man is what? Squared. Distance of separation what? Squared. We'll substitute it here. Then when you press this in your calculator, how do you press it in your calculator? Well, bring out your calculator. Have you bring out your calculator? Open the bracket. Look at what I mean by open bracket. This in your calculator. Press what? 9. Press shift. When I get this shift, have you pressed shift? Press log. Press 9. Have you pressed 9? Bring down your cursor down. Press times. Have you pressed times? Press 6. Have you pressed 6? This is 6. Have you pressed 6? Then press shift. Have you pressed shift for this place? Then press log again. Press minus 6. Then bring your cursor down. Press times. Press 2. Shift. Press log. Minus 6. Close the bracket. This is what we close the bracket. Then press division. Look at division. Side. Then you open this bracket again. Press 0.051. Close the bracket. Have you closed the bracket? Then you press this in your calculator. That means for square. If you see this in your calculator, press it immediately. It will apply this what? This 2. Then press equals to. When you press equals to, what you're going to have here? What you're going to have there is a full 1.52 nothing. 41.52 nothing. That's what you will have there for the force of 1 on 3. Charge 1 on 3. Then let us look for what? The force, the charge 2 on 3 we give. That's the force charge 2 we give on 3. Look at it. We are going to look for it. We'll still apply the same thing we did here. Can still apply what we have here again. I can clean here. Then we'll look at this. Let us look at it properly. I will have what? What I'm going to have, I will have F2 on 3 equals to what? K, Q, 2, Q3, all over distance of separation squared. Then I have to substitute the value. I will say where R on this, in this case, is what? Distance between Q2 and Q3. Look at it. Can we watch here? Can we look at our diagram here? This is Q2, Q3. Look at the distance of separation, which is minus 3.4 cm. Remember, it's a cm, it's in cm. Let me put it here. You have a cm, according to the question, is a cm. So you will have it minus 3.4 cm. Will I use this? No, I can't use this because it's a mixed unit. I will not convert it. I'll have what? Minus 3.4 divided by 100. And that gives me minus 0.034 meter. Then when I have done that, I have to substitute my value. Let me substitute my value. Substituting my value here, I will have f of 2 on 3 is equals to what? 9 times 10 raised to power 9 times what's Q2? Q2 is minus 50. Will I write that minus 50? Come over here. Minus 50. You remember, this minus, I will not use it anymore. It's just there to indicate that what the charge is negative. That's the direction. According to what I said, it's a vector quantity. So I'm not going to use it, the minus here again. I have already know the direction. By that, I have indicated the direction of force. So no need of my word to use it anymore. I just needed only the magnitude. Times what? 10 raised to the power minus 6. That's Q2. That's Q3, which is what? 2 times 10 raised to the power minus what? See, that's Q3. All over the distance of separation, which is what? Minus 0.034 all what? Square. Then when you press this in your calculator, as I explained on the first one, you open bracket, press 9, press shift, press 9, log, press 9, press times, press 50, press shift, press what? Log, press minus what? 6, press what? Times, press 2, press shift, press log, press minus 6, close the bracket, open bracket again, minus 0.034, close the bracket, square. That's what we did here. The same thing, just press 9, press time, shift, press log, press 9, press what? Times, press 50, press shift, press log, press minus 6, press times, press 2, press shift, press log, press minus 6, close the bracket, divide, press this in your calculator. You will have this, that the force of 2 on 3 will be, 2 on 3 will give you 778.55 Newton. Then the total force, which is resultant force, we have already written it here, which is what? Resultant force will become this plus what? This. You will add this to what? This. You give me what? The resultant force, which is the force on that Q2, Q3. Then I claim here to what? Put it down. Let us put it down. Then we'll have the resultant force Fr is equals to what? F3 is equals to F3, which is equals to, you close it now, look at yeah, which is will give me what? Which will give me F1 on what? 3 plus F2 on what? 3, which is equals to F1 on 3 is what? 41.52 plus 778.55, and that will give you, if you use your calculator, you have this 20.37 Newton as the answer of this question, which is what? F3, the force on F3 or resultant force. That's our answer. Then they asked us the what? The direction of the force. What's the direction of the force? You remember? What's the direction of the force? Look at it. The two force is directed in this way, right? Directed in this way. In the negative side of what? The direction of the force is what? In the negative side. In what? Negative side of what? X. In the what? Negative side of the what? X. The direction of force is what? In the direction of negative side of X. So what we will now say, the direction of force is on the negative side of x-axis. X what? Axis. Negative side of what? X what? Axis. You know, look at where they're pushing on negative side of axis. And that's what I have for you today. If you love what we are doing here, subscribe to this channel, comment, love the channel, subscribe for the next class. That's what I have for you today. Thank you.